This is a video that's going to work through the test questions for test number 1, the review questions, and this video covers questions 1 through 6. So question 1 on the review says, from the list of numbers, select all the rational numbers. Well, in order to answer that question, you guys have to remember what a rational number is. A rational number is anything that can be written as a fraction. So you have to look at each number individually and think about, could I write this number, such as the square root of 17, as a fraction? Well, the square root of 17, if you put it into your calculator, is a big, long decimal value. It's approximately 4.123105626. So it's a decimal that just keeps going on forever and ever. So therefore, the square root of 17 is not rational, or in other words, it would be considered irrational. The square root of 16 can actually be simplified, and it simplifies to 4, and then I can write 4 as a fraction because I can put it over 1. So the square root of 16 is a rational number. Hopefully it's obvious that 22 over 7 is a rational number because it is written as a fraction. 15 over 0 is not even a number mathematically. It is very undefined. Remember, we never have 0 in the denominator of a fraction, so it's not really even a number. So this one is not rational at all. Again, then when you look at the next line, you have negative 3/4, which again, hopefully that is obvious that it is a fraction. You have negative 5, which can be written as a fraction. It's negative 5 over 1, so it's rational. Negative 7.5 can also be written as a fraction. You could put it over 1, but it's actually, negative 15 halves. Okay, so we can write it as a fraction. So yes, it is. Typically, rational numbers are going to, if they're decimals, they're going to be what we call terminating, or they have a pattern to them. So 3.1414141414 is a repeating decimal because it repeats the 1, 4, and the little dots at the end imply it goes on forever and ever. So 3.14141414 that goes on forever would also be rational. But then when you look at the last one, 3.141141114, there's no pattern to it, and it goes on forever and ever. So again, it's another one of those big, long decimal numbers, and so therefore it is not rational. Question number 2 asks you to evaluate the expression negative 2x to the 4th plus 3x cubed minus 7x squared plus 6x plus 5 for x is negative 2. So to work that problem, and you may want to have a calculator handy, we're going to substitute negative 2 into the equation wherever there is an x, or into the expression. So we have negative 2 times negative 2 to the 4th plus 3 times negative 2 to the 3rd minus 7 times negative 2 squared plus 6 times negative 2 plus 5. And then I'm going to go back and do the math. Okay, I'm going to do it by hand. You can use your calculator, but be careful. If you're going to use your calculator, make sure to put parentheses around the negative 2. So we'd have negative 2 times negative 2 to the 4th, which would be negative 2 times negative 2 times negative 2 times negative 2 would be positive 16, plus 3 times negative 2 to the 3rd, negative 2 times negative 2 times negative 2 would be negative 8, minus 7 negative 2 squared. Negative 2 times negative 2 is positive 4. Minus 6 times negative 2 would be minus 12 plus 5. Okay, still got some math to do. Okay. So negative 2 times 16 is negative 32. Negative, or 3 times negative 8 is negative 24. Negative 7 times 4 is negative 28 minus 12 plus 5. So we have negative 32 plus 24. I'm going to go ahead and put those two together first. That gives me negative 56. Minus 28 minus 12 is minus 40 plus 5. Let's see, minus 56 and minus 40 make minus 96 plus 5 equals negative 91 is your final answer. Okay, again, you can plug it into your calculator and should be able to get the same answer. Question number 3 asks you to simplify the radical. You have the square root of 50, x to the 7th, y to the 10th. Again, the easiest way to do this is to break it down. So let's see. I would have 50 is 5 times 10, and 10 is 2 times 5. Okay, let me back up there for a second because we can put the 5s together. Okay, so you're going to have 5 times 5 times 2, 5 times 5 times 2, x to the 7th, y to the 10th. Then we're going to be looking for sets of 2 since it's a square root. So I have a set of 5. I have 1, 2, 3 sets of x with 1 left over. I have 1, 2, 3, 4, 5 sets of y. So I'm going to take out a 5, 3 x's, 5 y's, and left underneath the radical is a 2 and an x. All right, next, question number 4 says rationalize the denominator. It's 1 divided by the square root of 2. In this case, you have a single value in the denominator, so we need to force it to be a perfect square. So we have 1, 2, so we need a second 2. So I'm going to multiply the numerator by the square root of 2 as well as the denominator by square root of 2. So I have square root of 2 over square root of 4, but square root of 4 simplifies and becomes 2. So that 1 over the square root of 2 simplifies to square root 2 over 2. Question number 5 also asks you to rationalize the denominator, but this one is slightly different because you have a sum or 2 pieces, 2 parts in the denominator. So in this case, we have to use the conjugate. Remember, the conjugate is the same 2 numbers, so we're going to have square root of 2 and 3. The original one was plus, so I need a minus. You always have the same 2 partners in the conjugate, you have the opposite sign. So in this case, it would be negative. Again, with these, it's maybe better to put parentheses around the pieces so that you can multiply them. In the numerator, we simply are going to distribute the 3. So we have 3 times the square root of 2 minus 3 times 3 is 9 over, in the denominator, we have to FOIL it out using first outside, inside, last. So we have square root of 2 times square root of 2 which is square root of 4, minus 3 square root 2, plus 3 square root 2, minus 9. So I have 3 square root 2 minus 9 in the numerator. In the denominator, I'm going to simplify it just a little bit. Square root of 4 simplifies to 2. Minus 3 square root 2 plus 3 square root 2 zeroes out, and then I have minus 9. So I have 3 square root 2 minus 9 all over negative 7. Now, typically we don't leave the negative in the denominator, so what we would do here is multiply the numerator by negative 1 so that we end up with the negative 3 square root 2 plus 9 over 7. Now, either of these answers are acceptable. This one or this one. It's just that the last one here that I'm marking now is more the way you would see it mathematically. So if you're taking a multiple choice test, you may want to look for that particular answer. And finally, question number 6 asks you to factor 8x to the third minus 27y to the third. And you may think, well, Ms. Ralston, that doesn't factor. But it really does, because if you'll notice, you have exponents of 3, which makes me think about a cube. And I know that I have 2 special formulas for cubes. I have the difference of 2 cubes, and I have the sum of 2 cubes. Well, the other thing I notice is that I have this minus sign, which takes me to the idea of being a difference of 2 cubes. And it's a formula. So remember, if you have a cubed minus b cubed, it factors into a minus b times a squared plus ab, sorry about that, ab plus b squared. So we have to stop and think for a few minutes and think, okay, what did we cube to get 8? It's 2. What did we cube to get x cubed? It was an x. What did we cube to get 27? It's a 3. What did we cube to get y cubed? It was a y, and we have a minus sign between them. To get the second set of parentheses, there is a pattern here because you're going to square the first thing. So 2x squared would be 4x squared. You're going to square the 3y, so you have 9y squared. And then you multiply the 2 pieces together. So 2x times 3y would be 6xy. And then both pieces are positive. So there's the factorization of 8x cubed minus 27y cubed.